All right. Hello, everybody. Welcome to 5.6, How to Experiment Well. All right, let's get this set up. First thing we're going to talk about is random assignments. Of course, this should sound familiar. We've talked about randomization before. Random assignment means that treatments are assigned, obviously, to experimental units, which, oh, come on, here we go. Assigned to experimental units, or experimental units are assigned to treatments using a chance process. Okay, there we go. Yeah, so of course it just means that so not just like the people themselves are selected randomly, but the treatment assigned to them is assigned randomly. So like um you didn't just hand pick which people are going to get treatment A, which people are going to get treatment B. You have a random selection process. So for example, let's say you have your 50 people that you're sampling, and you want half to be in group A, half to be in group B. So you can put, 25 A's in a hat, 25 B's in a hat, mix them all up, and then those people can just grab out of the hat randomly. And then that's kind of a random chance to see who's assigned to which group. So that's kind of what we're talking about here, assigning them the treatment randomly. Replication, the idea that we should use enough subjects to create roughly equivalent groups. All right. And the idea that we should use enough subjects to create roughly equivalent groups. There you go. Sources of variability. One reason to keep other variables the same for each subject is to prevent confounding. Why is it always that? To prevent confounding. Right? If other variables are adjusting instead of just the singular variable that we want to be adjusted, then those other variables that are changing could impact the results. That's what confounding is, right? Confounding is having something else kind of stealing the credit for what's really going on with the experiment, why things are correlated with one another. You want just one variable to be the focus and have everything else be completely uniform. Um, yeah, making it easier to determine if one treatment is more effective than another. The second reason sorry. The second reason is, shouldn't have we, to reduce the variability in the response variable. Making it easier to determine if one treatment is more effective than another. Same reasoning. All right, well-designed experiment. So control involves making the experiment as similar as possible for experimental units in each treatment condition. Randomization refers to the practice of using chance methods to assign experimental units to treatments, mentioned that, and replication. The more experimental units in each treatment condition, the lower the variability of the dependent measures. We've talked about that before, right? This is basically saying increased sample size leads to reduced variability. That's basically what that is referring to. The more experimental units in each treatment condition, the lower the variability of the dependent measures. So again, essentially just saying the larger your sampling group, then the lower the variability will be, which basically just means a more accurate result. All right, so let's get into our first example. If Miss Tierney's class, or no, in Miss Tierney's class, 30 students volunteer to participate in an experiment to determine if chewing mint gum during a test will increase their score on that test. Miss Tierney will provide mint gum for half of the students, while the other half will not chew gum. The same test will be given to every student. Describe how you would randomly assign students to each treatment. So I kind of mentioned this before, right? But what you could do is you could put, uh, 30 slips of paper in a hat and have half of them be, say like gum, and half of them say no gum, right? And then they can just choose randomly. And those that say gum will choose the gum, and those that say no gum will not choose the gum. So kind of just using the slips of paper method there. So let's fill that in. I'm gonna go ahead and just pause it and fill it in so that you guys don't have to see me write it. So just give me 1 second. All right, so there's kind of my brief explanation there. How about if we used a random number generator? So you can label each student, of course, with a number from like 1 to 30, then randomly generate 15 different numbers from 1 to 30. The first 15 numbers that pop up will be the ones that get to chew gum, and the remaining ones that were not selected will be the ones who do not chew gum. So again, I'll write that down and we'll move on. All right, so there's basically what I said a moment ago. All right, let's move on to our example on the right here. All right, so you may have heard that Botox, which I'm not even gonna say what that is, but is used for cosmetic surgery, but could it have other beneficial uses? 31 patients who suffered chronic lower back pain were randomly assigned to receive 200 units of either Botox or saline through 5 injections at 5 different locations in their backs. The saline injection was not expected to reduce pain, but was given as a placebo treatment. After 8 weeks, 10 of the 15 Botox patients, which is 67% basically, had pain relief compared to 3 of the 16 who had the saline product. Why was it important to measure each patient 8 weeks after treatment? So if patients were measured at differing times, the researchers wouldn't know if the type of injection or the time was the cause of changes in back pain. So, if they're all measured at the same time, then time is no longer variable, right? That makes sense. Because, like, if I measured some people at 8 weeks and then I measured some people at 9 weeks, maybe 9 weeks was just longer to feel better in general. But to eliminate time from being a factor, if everybody's measured at the same time, then there's no variability in that. There's no variability in time because it's all the same. It's all uniform for everyone. So the only thing that was different then was, well, how well are these people feeling at that specific time? Yeah, so it's to eliminate time from being considered a variable here and a factor in their kind of their healing process. So let me write that down again, and I will come back to you. All right, so again, there's what I had mentioned a moment ago written out. So you guys, if you want to pause the screen and copy it, you can. Question B says, why was it important to give each patient the same dosage of Botox or saline? Or of course, if you give some more and some less, then those who got more might be more likely to heal than those who got less. So then it's the amount that you're giving that you're measuring. But we don't want to measure if more is better or less is better. We just want to measure if Botox itself works better than saline. So if we keep it the same amount for everything, then we can't say, oh, this person got more, so that's why they're better, or this person got less, that's why they didn't. That's no longer a factor, right? It's simply just how does Botox compare with saline? The amounts were all the same, so we can't argue that the amount helped or hurt anybody here. So again, I'm gonna write that down and we'll come back to you. There you go. And then our final example down at the bottom says, can watching fast-paced cartoons reduce the mental functioning of children? 64-year-old children were randomly divided into 3 groups. One group was shown a fast-paced cartoon, one group was shown an educational cartoon, and one group was given art supplies and instructed to draw pictures. All the children spent 9 minutes watching the cartoon or drawing. Afterward, the 4-year-olds who watched the fast-paced cartoon scored significantly worse than the other 2 groups on 4 different tests that measured brain function. Explain the purpose of the random assignment in the context of this experiment. So the purpose of random assignment is to avoid confounding by creating 3 groups of 4-year-olds that were roughly equivalent at the beginning of the experiment. So yeah, the idea there is if you give random assignment, then it kind of creates that, what we said earlier, that replication. The idea that we should use enough subjects to create roughly equivalent groups. And it just helps with that part of an experimental design to make sure, what am I trying to say here? To make sure that there's no other confounding variable going on. All right, so let me write this in and then I will maybe talk a little bit more about it but that'll be it. So give me pause the screen, let me fill this in so you guys don't have to watch me write again. All right. So there you go, there you have it. Just got done writing it. So you pause the screen if you need to fill it in, or again, I just have this answer key online. So hopefully this helps a little bit. Yeah, if you guys have any other questions, let me know. But yeah, you get work on your skill check and I'll see you next time. Bye for now.